Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You're watching Learn and Teach by Sir Ayaz. So I will continue my video session for past papers, and this time I have selected paper 42 of 5070, and it's of October-November 2023. Paper 4, alternative to practical, the time 1 hour. You have to answer all the questions in this paper. You may use calculator. The total mark for this paper is 40. Notes for use in qualitative analysis are provided in the question paper. You will have notes for use in qualitative analysis. These are the tests for anions. Then you have tests for cations. Then you have tests for gases, as well as flame tests for metal ions. So let's start the paper. Here's question number 1. A student investigates the electrolysis of concentrated aqueous sodium chloride. Figure 1.1 shows the apparatus the student uses. Figure 1.1, we have apparatus X. Electrodes, they are of graphite, and there's a concentrated aqueous sodium chloride. One of the electrode, which is positive, we know that positive electrode is anode. You can see the bubbles. These bubbles are of chlorine gas. A, name apparatus X. Now these are the inverted test tubes. So you write test tube. B, give a reason why iron electrodes are not used during this electrolysis. You all know that iron is reactive metal. So you can simply write it's not inert or reactive. Iron is reactive or not inert. Inert means unreactive. Moving to next part, C. Chlorine gas is produced at the anode during this electrolysis. Describe and explain one safety precaution the student takes during this electrolysis. Chlorine is a toxic and harmful gas. So safety precaution must be use of a fume cupboard. Use a fume cupboard. Or you can even use well-ventilated space. Well-ventilated space. The reason is that they are asking about the explanation. So you write the reason. Chlorine is toxic or harmful. Chlorine is toxic or harmful gas. D. A different gas is produced at the cathode during this electrolysis. Name the gas produced, describe a test, and its result to confirm the identity of the gas. Now look at the solution. It's of concentrated aqueous sodium chloride, which means you can't get sodium. You can't get sodium among the ions getting discharged at cathode. So at cathode, it must be H positive ion. At cathode, it must be H positive ion, because H positive ion is less reactive than sodium. Or you can quote ease of discharge or difficulty of discharge, like H positive ion have low difficulty of discharge or high ease of discharge as compared to Na positive ion. So you will definitely get the hydrogen gas produced at cathode. H positive ion will gain electron and produces hydrogen gas. So you write hydrogen gas. Description of test and result, it pops up with the lighted splint. Pops up with lighted splint. Moving to next question. Question number 2. Sulfuric acid H2SO4 is neutralized when it is added to aqueous sodium hydroxide NaOH. Here's the reaction equation. H2SO4 plus 2NaOH gives Na2SO4 plus 2H2O. The reaction is exothermic. P is 1.2 mole per dm cube aqueous sodium hydroxide. Q is dilute sulfuric acid. A student determines the concentration of sulfuric acid in Q. The student does 6 experiments. The student, in step number 1, uses a volumetric pipette to add 25 centimeter cube of P to a plastic cup. Step 2 uses a measuring cylinder to add 20 centimeter cube of distilled water to the plastic cup. In step 3, stirs the mixture in the cup with the thermometer and records its temperature to the nearest 0.5 degrees centigrade. In step number 4, uses a burette to add 5 centimeter cube of Q to the plastic cup and stirs. In step 5, student records the highest temperature reached. You see, the student is continuously stirring the mixture so that there will be even distribution of heat in the cup. In step number 6, student empties the plastic cup and rinses it with water. In step 7, the student repeats steps 1 to 6 using 5 different volumes of distilled water and Q so that the total volume in the cup is always 50 centimeter cube. The students' results are in table 2.1. So here's table 2.1. Remember, all these will give 50 centimeter cube. I can see some blanks here. Complete table 2.1 by filling in the 3 missing values. In experiment number 1, the temperature rise is missing. So you have to subtract 23 from 25.5. 25.5 minus 23 will get 2.5 degrees centigrade. Experiment number 3, where volume of Q is missing. 25 plus 10 is 35. So 50 minus 35. 50 minus 35, 15. So you have to write 15 here. Experiment number 6, 25, volume of water missing. Then you have volume of Q in centimeter cube, 25. So it must be 0 in order to get 50 centimeter cube. This is all we have. Parts of the thermometer used in experiment 3 are shown in figure 2.1. The liquid levels inside the thermometer are missing. Complete figure 2.1 by drawing in the liquid level to show the initial temperature in experiment 3, the highest temperature reached in experiment 3. So experiment 3, where is experiment 3? Here is experiment 3. Initial temperature, it's 25 and the highest temperature 32.5. 25 and 32.5. So initial temperature is 25, must be like this. Highest temperature 32.5. Now, part C, draw a graph of temperature rise against volume of Q on the grid in figure 2.2. You should plot the point 0, 0 as there is no temperature rise when no Q is added. Plot the temperature rises and volumes of Q from table 2.1. Draw a straight line of best fit for the first 4 points. Draw a straight line of best fit for the last 3 points. Extend the line so that they intersect. So we have temperature rise against volume of Q. So temperature. So I'm first of all writing down the temperature rise. So we have temperature rise 2.5, 5, 7.5, and 8. Two point five, 7, sorry, 5, 7.5, and 8. 5, 7.5, and 8. There will be 6 experiments. So the last 3 readings must be 8. Now, what about volume of Q? Volume of Q. 5, 10, 15, 18, 20, 25. 5, 10, 15, 18, 20, 25. Now I'm plotting. On x-axis, we are having volume of Q. So we have one volume that will be here, 5 and 10. Then we have 15. We have 18. It must be here, 18, 20, and 25. What about the temperature? 2.5. 2.5 degrees centigrade rise in temperature. It must be between 3 and 2. It must be here. 2.5. 5. Then we have 7.5. It must be between 8 and 7. And then we have 8. That's all we are having. So for volume 5, one point must be here. For volume of 10, for volume of 15, and for 18, 20, and 25, we have 8 degrees centigrade rise in temperature. Now let's join these lines. Now see the intersecting point. This is the intersecting point. See this intersecting point. It must be 16. 16 or 16.5. 16 or 16.5. Both are acceptable. So moving to next point, next question. Part D. The point where the two lines intersect indicates the volume of Q that exactly neutralizes 25 centimeter cube of P. Determine the volume of Q where the two lines on the graph intersect. So we have 16 or 16.5 centimeter cube. I am taking 16. E. P is 1.2 mole per dm cube aqueous sodium hydroxide. Use your answer to D to calculate the concentration of sulfuric acid in Q. Now, in this case, you can apply the equation that is M1 V1 by N1 is equal to M2 V2 and N2 to find the concentration of sulfuric acid. N is the number of reacting moles. For example, for sodium hydroxide, if I am using N1, it must be 2 moles for sodium hydroxide. So N2 must be of H2SO4, which is 1 in this case, 1 mole. So volume V1 for sodium hydroxide, M1 for sodium hydroxide, V2 for H2SO4, and M2 for H2SO4. We need to calculate the concentration of sulfuric acid. So I will write question mark for M2 so that you will remember that you need to calculate the M2. What about volume? So the volume we got 16. This is the volume which neutralizes 25 centimeter cube of P. And P is sodium hydroxide. Sodium hydroxide, the volume of sodium hydroxide is 25 centimeter cube. And the volume that is utilized in neutralizing sodium hydroxide is of sulfuric acid, which is 16 centimeter cube in this case. What about the concentration of sodium hydroxide is given here, 1.25 mole per dm cube. Rearrange this equation, we will get M2 is equal to M1 V1 by N1 multiply by N2 and divided by V2. Putting the values, M1 is 1.25 multiplied by V1 is 25, N2 is 1, N1 is 2, and V2 is 16. Let's solve this. 1.25 multiplied by 25 divided by 2 divided by 16. 0.9765. 0.9765 will be the concentration of sulfuric acid. F. Describe and explain what happens to the gradient of the straight line for the first 4 points on the graph if a metal cup is used instead of a plastic cup. Now, metal cup, it's a good conductor of heat. Plastic is insulator. Plastic is insulator, while metal cup is good conductor of heat. So you will definitely get less steeper line in this case. So you'll write gradient less steep. Gradient less steep due to loss of heat to the surrounding. You can write more energy lost to the surrounding or transferred. More energy transferred or loss to the surrounding. So part G, a burette may be used instead of a measuring cylinder to measure the volume of water in these experiments. Suggest how this improves the experiments. Definitely measuring cylinder have less precision, burette have high precision, so you can write improves the precision. Improves the precision. Number H, state the dependent variable in this set of experiments. Definitely, it's the temperature rise. That's the dependent variable. So you'll write temperature rise. Now, question number 3 is student investigates solid Y and solution Z. Solid Y is white and contains carbonate ions. The test the student does on Y are shown in table 3.1. Some of the observations for these tests are also shown. Table is table 3.1. There's a test on solid Y and observation. We have experiment 1, 2, and 3. So number 1, predict the identity of the gas produced in test 1. Describe how the student tests the gas to confirm its identity. So if you look at this, you are adding excess of sulfuric acid to Y in a boiling tube, and we see the effervescence. It must be due to CO2. Why? Because Y, it contains carbonate ions. Mentioned in the question, carbonate ion. That's why the effervescence is produced due to carbon dioxide. So you write carbon dioxide or CO2. Carbon dioxide or CO2. Now, test and observations, lime water goes milky or cloudy. Lime water goes milky or cloudy. If you don't remember the test, you can look at the test here, carbonate ion. See, here's the carbonate ion. The test results, effervescence, carbon dioxide produced. And the test for carbon dioxide gas, it's a gas. So test for carbon dioxide gas, you will find it here. You see, it turns lime water milky. So you can write turns lime water milky or goes milky. Number 2, the solution produced in test 1 contains an anion. Name a reagent that reacts with this anion to form a white precipitate when added to the solution produced in test 1 after the addition of dilute nitric acid. So in test 1, they are containing anion. And they are saying that's producing white precipitate. After addition of acid, what will be the reagent, name of the reagent that will turn it to produces white precipitate? So if you look at the anions list, we have chloride ion that produces white precipitate after acidification with dilute nitric acid, then adding aqueous silver nitrate, and sulfate, which also produces white precipitate after adding barium nitrate along with nitric acid. Now see, they are saying look at this. Solid Y is now solution. They are saying solution produced in test 1. So solution produced in test 1, it has already lost carbonate ion. You see, it has lost carbonate ion. So the solution, it must be having sulfate ion, which is coming from sulfuric acid. So solution must contain sulfate or SO4 minus 2 ion. So the reagent must be barium nitrate in this case. So I will write barium nitrate, aqueous barium nitrate. Aqueous barium nitrate. Moving to next part, part 3. The observations for test 3 are incomplete. State one other observation the student makes in test 3. Test 3. Moving to this table. Here's test 3. Add more aqueous sodium hydroxide to the mixture from test 2 until a further change is seen. So what change we have observed? We observed this white precipitate. They are saying white precipitate dissolves. So this sodium hydroxide test is for the cations. You see, cations are test, cations, white precipitate. Which of these are producing white precipitate with sodium hydroxide? It's aluminum 3+, calcium 3+, and zinc 3+, zinc 2+. They all are producing white precipitate. They all are. And they are saying soluble in excess. Soluble in excess. Giving a colorless solution. Giving a colorless solution for Ca2+, insoluble in excess. So they are saying white precipitate dissolves. When they are saying white precipitate dissolves, so it must be giving a colorless solution. It can't be insoluble in excess. Giving a colorless solution. So this must be the statement which is missing in this case. So you write colorless solution for part 3. So I will write colorless solution. Number 4, solid Y contains only one cation. The student cannot identify the cation from the observations in table 3.1. Use table 3.1 to name the 2 cations which could be present in Y. So if you look at this table, what they are saying, the test for cations in number 2 and number 3, white precipitate. And white precipitate, it dissolves. It dissolves. So for Al3+ and Zn2+, the white precipitate dissolves or soluble in excess. So it must be containing these 2 ions. So you will write aluminum and zinc. Aluminium and zinc. Number 5, describe an additional test that the student does on the solution produced in test 1 to identify the cation in Y. Now, additional test for these cation must be of aqueous ammonia. This will help in confirming the presence of the right cation. So you'll write aqueous, add aqueous ammonia, add aqueous ammonia, until a change is seen. Until a change is seen. Add aqueous, then you have to add aqueous, excess aqueous ammonia. Then you will be able to identify the correct cation in this case. B, solution Z contains one cation and one anion. The cation contains 2 non-metals. The student, number 1, the student adds aqueous sodium hydroxide to Z in a boiling tube. Describe how the student completes this test to identify the cation in Z. Now they are saying 2 non-metals in this cation. So if you look at the list of the cations, it's only ammonium ion that's containing 2 non-metals. We have nitrogen and hydrogen. What else they are asking? They are asking, describe how the student completes the test. Initially, they said that student adds aqueous sodium hydroxide in a boiling tube. So you must be writing warm or boil the mixture. Then test the gas with damp red litmus. Litmus turns blue. Boil mixture test gas with damp litmus. It must be red. Then you write litmus turns blue. This confirms the presence of the ammonium ion. Ammonium ion here. Next part, the student adds dilute nitric acid and then aqueous silver nitrate to Z. A precipitate is formed. It is difficult to tell if the precipitate is white or cream in color. Describe how the student uses separate aqueous solutions of a chloride and a bromide to decide the color of the precipitate. Definitely, you have to test the separate solution with silver nitrate and nitric acid and compare the result. That is the color of precipitate. Test the separate solution. With silver nitrate and nitric acid. Then compare color of precipitate. Compare color of PPT to the color of the PPT form. Number 3, the student adds dilute nitric acid and then aqueous barium nitrate to Z. Predict the expected observation. Definitely it does not contain sulfate ion because this is a test for the sulfate ion. These are the tests for the anions in C here. It's a test for the sulfate ion, nitric acid and barium nitrate. So it's absent here. So you write colorless solution. Last question. Copper 2 sulfate is a salt used to kill pests on plant leaves. Copper 2 sulfate is prepared by neutralizing dilute sulfuric acid with solid copper 2 oxide. Plan an experiment to prepare pure dry crystals of copper 2 sulfate. Your plan should include the use of common laboratory apparatus, dilute sulfuric acid, solid copper 2 oxide. No other chemicals should be used. Your plan should include the apparatus needed, the method to use. You may draw a diagram to help answer the question. So this is very easy one. So you can write any 6 from these, any 6 points from these, because the total mark for this question is, you can see the marks, it's 6. So you can write any 6 from. So in the first step, you must be adding solid copper 2 oxide to warm dilute sulfuric acid. Add solid copper 2 oxide to warm. Remember, you have to warm it because they said that it's a dilute solution. So you have to warm it because the copper 2 oxide will only react with the acid. So you must have warm acid to warm sulfuric acid. Then stir it. Stir it. Using glass rod. In the first step, you can mention the name of the apparatus, like you are having sulfuric acid in the beaker. Now in the next step, add until no more solid dissolves or in excess, solid in excess. It means no more is reacting. The next part must be filter. You filter the mixture using filter funnel. Filter the mixture using filter funnel. In the next step, you will evaporate through gentle heating. Evaporate through gentle heating. Overheating should be avoided because in this case you may have salt of crystallization, water of crystallization. Evaporate through gentle heating, then allow to cool or crystallize and dry in air. Dry the crystals. For the apparatus, you can draw these apparatus, like you can use conical flask and name the apparatus also. This is conical flask. You can draw beaker. You are using heating the mixture, so you can also draw the Bunsen burner in this case. Bunsen burner. Also, if you want, you can draw the glass rod for stirrer or glass rod. For filtration, you're using filter funnel, so you can draw the filter funnel. Let me label it. These are all the options you have for this question. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.